Hello there. Welcome back to Steam TV. Today we are going to go through systems of equations using Cramer's rule. All right, now you probably remember there are multiple ways to solve the systems of equations. Back in algebra, you learned the methods of substitution, elimination, things along those lines. You could also use matrices. You could use row-reduced echelon form to solve a systems of equations. But today, in particular, I'm going to go through Cramer's rule. Okay, so I'm going to walk through Cramer's rule. And basically, Cramer's rule allows us to solve a simultaneous set linear of equations. And so we're basically going to get these substitutional matrices, which we have done before. This is where we have basically row and column. Oops. Let's just say, for example, we have 2, 3, 5, right? -1, -4, 2, 2, -2, and 10. Right? We do that. That gives us this gives us one matrix in the A position, in the for 2. Okay, and then so on and so forth in B and C. So essentially, what we're going to do here is we're going to basically take an equation, put it in a coefficient matrix, which we essentially already did. The first thing we want to do is also compute the determinant. Okay, so we'll call this matrix A, and this is our example. We'll call this matrix A. Okay, and for our determinant, we're basically going to take 2 times, and again, remember, we're going to go through the row and column so that we're essentially left with -4, 2, -2, and 10. Okay. And then, man, I really got to get this pen fixed here. Okay. And then we're going to take the rest of our values accordingly. So check with me and make sure you get the same answer. Okay. Give me 1 second. Okay, so this is what you should have gotten. Okay. We take the determinant of the actual matrix. All right. We're going to take 2, take what's left over, which is that. Okay. Then we're going to we're going to go for -1, 4, and 2 the next column. Okay, and we're left with 3, 5, -2, and 10, which is what we got here. 1 is the value that is intersected, so that's why that's my coefficient of that matrix. And then finally, the last row in the first column again will give me those values. Anyway, standard determinant solving, and here I'll just do one really quick. 3 times 2 is 6, right? Minus -4 times 5 is a -20, which gets me 26 times 2 from that 2 out front will get me to 52. Okay, so essentially that's how I solved all of these. All right, got 164 for my determinant. All right, now I'm looking at the equation. Okay, my equation, and I should say let D be the determinant instead. So this is really D, which is the determinant of A, which is 164. So basically, I'm at this point. I solved for my D. Now I'm going to come down to this point, right? Because now I want to find what my solutions are, my X, Y, and Z's. Those are my solutions. So in order to find my solutions, those are my unknowns. I'm just simply going to plug into these matrices. And now D1, D2, and D3, okay, is everything on my left side of the equation, okay? And so in which case, let's take, and here, let me rewrite this. All right, so to avoid any confusion, I honestly should have just gave the equations to begin with, all right? But essentially what this is it could be anything like 2a, and we'll say plus 3b, right? Plus 5c is equal to some number, which let's just say is 2. Right, so basically the equations on everything is equal to 2. Let's do 3 and 6. Okay. So that is my D. My little d is 2, 3, and 6. Okay. Make this a little neater for. Okay. That's my little d. So essentially what I'm going to do is I'm going to put 2, 3, and 6 here. B1 is 3, -4, and -2. Okay. And then 5, 2, and a -10. Solve that determinant. And then divide it by the determinant of my coefficient matrix from original. So that's my my superstitial or my substitutional matrix. Okay. Then I'm going to do the same operation for y once again, but instead I'm going to take 2, -1, and 2. I'm going to take these two columns whole as they are, and this column is going to be replaced with d. Okay. Essentially is what I'm doing here. I'm just moving the solution to multiple different spots by doing a substitution. That's why it's called a substitutional matrix. Okay, so coming back down here, I'm going to take my 2, -1, and 2. I guess it would help if I changed the tool I was using, right? 2, -1, and 2. Then I'm going to take my D1, right? My D1, 2, and 3, and then 5, 2, and 10. -10. Solve that one, divide it over 164, get my numbers for y. So that's how I get y. This is how I get x. And now for z, same thing, 2, -1, and 2, except now I'm substituting 3, -4, -2. And now I'm going to substitute 5, 2, and -10 into my third column, divided over 164. That will give me z. Okay, so that's essentially the crash course on how to solve equations with matrices. I'm not going to go through the general operations here. That's not too bad. It's just adding and dividing. And getting the determinants of these. All of these is essentially the same work as what we did up here. Okay. Except the 3x3, if you remember from my previous video, if you look at the video on how to solve a determinant of a 3x3, okay, we'll just do that really quick. If you want to stay a little longer, B2, B3, C1, C2, and C3. And now remember what I do is I take the same matrix, the first two columns, right? And I want to take 3 values. 3 values, 3 values. Going this way is positive, going this way is negative. And then I'm going to subtract this, this, and that, multiplied together. Okay, so essentially, that's how we do this. Questions, comments, please leave them and in the below. And please like, comment, and subscribe.